All right. So we're talking about decimals. And the first thing I want to talk to you about decimals is another way to represent numbers. Because that's what a decimal is, period. That's what a fraction was. You'll see that constant pattern with mathematics that we're just looking at different ways to represent values. But for this, we're going to be looking at scientific notation and engineering notation. Well, scientific notation comes from the fact that we like to think of things in terms of 10. Why? Because we have 10 fingers, 10 toes. That's even why we call them decimals. That's why our place values are based off of powers of 10, because we understand things better in tens. So, with that in mind, we have scientific notation. And the way scientific notation works is it takes a number. So, let's just make up a random number here. Let's do 198. And what we like to do with that number now, 198, is we want to change the way this is written. We want to change the way this is represented to be between the numbers 1 and the number 10. Why do we want to do that? Because what we're trying to do is give a better estimation of a certain place value, how many we have. So it's a better way to see the value, a better way to estimate it, a better way to round it in your mind if you saw it. So the way this works is we want to change this to basically count whatever the highest place value is and count how many we have of that. So in this instance, we're looking at the hundreds place because we have 198. The highest place value that we have is 100. So we want to estimate, well, how many hundreds would that be? Well, many of you are saying, oh, that's close to 200. That's easy. Right. So it would be 200s. So when we change the way this is written, when you see the final product, the final answer, when you see 198 written in scientific notation, you will easily say, okay, well, that's close to 200. Well, the way we do this first is we take our number and we place the decimal that, of course, normally appears at the end here, after the 8. And what we're going to do is we want to move it so that we have a new number, that's between 1 and 10. So if we do that, this will become 1.98, and it's okay to say 1.98. Most of the world is okay with saying it now. If you say it 1 and 98 hundredths, someone would understand that too. But 1.98 is the general way of saying these now, and it makes it a lot easier for others to understand. Oh wait, we can't just say 198 is 1.98. They aren't the same value, right? $198 is not the same as $1.98. Well, we can let whoever is looking at this know that we're talking about 1.98 hundredths. Hundreds. That's what I said there, hundreds. Because remember, we're trying to show this as an estimate or an easier way to represent, so that in your mind you can estimate how many you have, how many hundreds we have. And remember, we said we're going to have close to 200s. Well, to do that, we take the new number we have, that's between 1 and 10, and we're going to multiply that times 10 raised to a certain power. And that power should represent what place value that we're at. Well, we're in the hundreds place. That would be 2 to the second power. All right? When I look at this, I see 1.98. I know that I have 2 of whatever this is. And 10 to the second power, or 2 zeros at the end. So remember, a cool thing you can do with tens, and to make it easy when doing powers of 10, is that the exponent tells you how many zeros you have. So in this case, this would be 100. So this would be, we have close to 200s. Right? All right, and that's how you do scientific notation. So this is kind of new for me. I'm having trouble with it. I bet it's not really new for you. How many of you have ever heard anyone say there are about 2.1 billion people in the world or something like that? I just made up that number, but you've heard that saying before, or so and so is worth about $1.3 million. That is scientific notation. It's just written with the word instead. So $1.3 million, we would have 1.3, because that's written in this format already, right? Times 10 to a certain power. What power do we want? Well, we're talking millions, so that must be 6 zeros, right? that would be the same as saying 1.3 million. Okay, so you have seen this before. It's just hasn't been told to you that's scientific notation. Why do you even call it scientific? Because whenever you're working with numbers in science, sometimes they get really big, sometimes they get really small. This helps you estimate and, as I said earlier, understand and kind of get a visual picture of how much you have of something. So with the 198, we can just think of it as having 1.98 hundredths. Okay, makes it a lot simpler. With the 1.3 million, if you, instead of you writing out the number 1.3 million, instead of you writing out the number 1, 300, 000, you just know you have 1.3 million. So it makes it a lot easier for you to understand, to visualize, even to write it. But those are all with positive exponents, and we know that we can have negative exponents, right? These are also all whole numbers, and we know that we can have fractions of whole numbers. We can have decimals. So what about if it's going the other way? Well, let's see what happens. So if we go the other way, say we have 0.0378. Okay? Well, we're going to do the same thing. We want this value to be between 1 and 10. So how do we get it between 1 and 10? Well, we'll take this decimal, and instead of moving it to the left, we're going to move it to the right. So this 0.0378 is going to become 3.78 times 10 to a certain power. Well, what power is that going to be? Well, let's see what place value we're at. The highest place value that's given here is the hundredths place. Hundredths place. Well, hundredths, that'll be 2, right? So that'll be a -2 power. And that's it. So your answer for 0.0378 would be 3.78 times 10 to the -2nd power. And that is how you would change that to scientific notation. Okay, that's pretty simple, right? Yes. So take your number, move the decimal so that your new number is between 1 and 10. And with that being said, you don't want 10 to be your number. 1 to 10 means that you can start at 1, but it can't be 10. It can be 9.99999999999999999. You get what I'm saying? But it can't actually be 10. Because if it was 10, we could just say that that's 110, right? All right. So if you had the number 10 and you wrote that in scientific notation, you would actually just write 1.0 times 10 to the first, or 1 times 10 to the first. Okay. All right. That's scientific notation.